pin details, how many pins it has, and each pin, what is the functioning of each pins, and how your RC circuit works. In this session, we'll be studying about monostable multivibrator, bistable multivibrator, and astable multivibrator. So there is a lot of difference between your monostable, bistable, and astable. So when it comes to monostable mode, it produces a precise timer for a fixed time duration. It's a fixed time duration. That is, from an external pulse. If I give an external pulse as a trigger to the 555, it generates a particular pulse. And that pulse will be high until your resistor combinations with your pin number 7. That I will show you the diagram, how your resistor is connected to your pin number 7 and how your pin number 6 will be working to produce a particular pulse. So that is monostable. Monostable, what happens when there is a external pulse to the 555, it produces a precise time for a fixed duration. That is the reason we call it as a fixed duration. When there is a pulse to this, it will start generating a particular pulse, and it is a fixed duration, then it goes off. So it is called monostable. Now coming to bistable, that is only specifies. Bi means it's a two-stage. We are not giving any triggering pulse to this. We are using R and C circuit. It's called tank circuit. With combination of this resistor and capacitor, we can generate some pulse. So if I want a particular pulse of a frequency of 10 kilowatts, yes, I can build by using R and C capacitors. So in bistable, the output will be on, off, on, off, on, off, so on. It goes on until your 555 is in on condition. So that is your bistable. Your astable is almost similar to bistable. The only difference between your bistable and astable is bistable produces flip-flop output. That is T on, T off, T on, T off, T on, and T off. But when it comes to astable multivibrators, it produces very stable oscillations, which usually generating high accuracy free running waveform, which can give high accuracy free running waveforms. We usually call it as a frequency output. So the main difference between bistable and multivibrator is bistable gives a output as your flip-flop, how your flip-flop gives a switching action and on and off, it will work. Astable produces a particular frequency, stable high accuracy frequency. That is called astable multivibrator. Okay, so you understood what are the types of multivibrators by using 555. Let us go to the next slide. Okay, you can see here a monostable multivibrator. That's the time is calculated by 1 into that is 1.1 into R1 into C1, where T is in seconds, R in ohms, and C in farads. Here, okay, you can observe here it's in monostable operation. In monostable operations, we are using two resistors, R1 and R2. So R1 and R2, if the trigger pulse is given to pin number 2, and your 6 and 7 are shorted with a resistor R1. As you can see here, the pulse is given to pin number 2. The pulse is nothing but a negative pulse. So high to low pulse, a negative pulse is given. So until this switch is off, your output remains 0. When the switch, that means one particular pulse given to pin number 2, then your output will be on, or it goes from 0 to 1, and it will be stable until a particular duration. The duration is nothing but t. So that duration is calculated by this particular formula. So it is R1 into C1 into 1 into 1.1. By these calculations, you will get t, the time duration. So according to your R1 and C1, your output remains high. After t, the time duration, it goes to low. So you are able to understand. So see properly here. There is a trigger pulse here. So in the trigger pulses, the voltage should be greater than 1/3 of VCC. For a trigger pulse, the voltage should be greater than 1/3 of VCC. So I am giving a negative pulse. It's a low triggered. So when I given a low triggered pulse, your capacitor, where is your capacitor? This is C1. Your C1 starts charging. Slowly it will start charging until it reaches 2/3 of VCC. Until it reaches 2/3 of VCC, your output starts rising and it remains high until your capacitor starts discharging. So the concept is something like this. So 1/3 of VCC to greater than 2/3 of VCC, your output remains high, and after it reaches greater than 2.33, it goes to low. So high and it goes to low. Within this period, your capacitor will start charging and it goes to discharge. So until charging to discharge period, your output remains high. So remaining time it will be 0. So this is called monostable multivibrator. A very simple monostable multivibrator, where we use this formula to generate the time durations, thereby calculating R1 and C1. So hope you have understood how your monostable multivibrator will work. We'll go for the next slide. So coming to monostable, it requires to produce a time delay within a circuit. This is a problem. If 10 microfarad timing capacitor is used, calculate the value of the resistor required to produce a minimum output time delay of 500 milliseconds. So they are given two things. One is C, capacitor they are given, and they are asking us to find out what will be the resistor. So what should be the resistance? What is the formula? Formula is nothing but T is equal to 1.1 into R into C. So what they are given here? They are given 10 microfarad. They are also given time. So 500 milliseconds. 500 milliseconds. You need to find R. R need to be found out. So let us rearrange the equation. So 500 milliseconds is the same as saying 0.5 second. So by rearranging the formula, see, R is equal to T divided by 1.1 into C. So what is T? 0.5 second divided by 1.1 into capacitor value is 10 microfarad. 10 microfarad. So if you calculate this, you will be getting 45.5 kilohertz. Okay. So the problem here is you are getting a resistance value of 45.5 kilohertz. So there are some standard resistors which are available in the market. So 47 is not a standard resistor which is available in the market. So to get a standard resistor, you have to search in the internet or you have to search in the market. So the nearest approximate standard resistor is 47 kilo ohm. You are able to understand, I think. 45.5 is not a standard resistor. which is not available in the market. The availability of resistors in the market will be changed. Let us say I have 1K. 1K is available. 2.2 kilo ohm is available. 3 is not available. 4.7 kilo ohm is available. So on. 10 kilo ohm is available. 11 kilo ohm is not available. It is not available. 12K is not available. So on. So which are the resistors which are available in the market? We have to take that. So according to this circuit, 45.5 kilo ohm is not available in the market. So we are choosing a 47 kilo ohm, which is approximately. And your output time will vary according to your calculations. So instead of 500 milliseconds, it will be a little bit greater than your 500 milliseconds, around 517 milliseconds. So that is your monostable, how your output frequency can be calculated, how R can be calculated, how C can be calculated. Okay, hope you have understood this concept. Okay, next we'll start with bistable multivibrators. So coming to bistable multivibrators, a bistable is one of the simplest circuit we can build using Simplified timer oscillator chip. This bistable configuration does not use any RC timing network. This is important. RC timing network is not used in bistable as per this circuit to produce an output waveform. So no equations are required to calculate here. Set and reset. We can see here one is set and one is reset. So there is no capacitor. Capacitor is not present. So let us see. The switching of the output waveform is achieved by controlling the trigger and reset inputs of the 555 timer. Try to understand. The switching of the output waveform. So output waveform. Here we are speaking about bistable. So output waveform. Switching of output waveform from low to high or high to low is achieved by controlling the trigger and reset input. So by pin number 2 and pin number 4. Okay. After which are held high by two pull-up resistors R1 and R2. Okay, the question is, what is this pull-up resistor? Pull-up resistor is something like, if I want to keep a particular line high always, so I'll call it as a pull-up resistor. Let us take this X point where I need to keep this voltage always high. So what I can do is I can connect one resistor here, connect to this wire and connect this to plus VCC, and I can have a switch to this, to the ground. Until your switch is in off condition, your X value will be equal to high, that is equal to VCC, that is equal to VCC. When the switch is closed, the current flows through the easiest or least resistance path, then your output goes to 0. So this is called pull-up resistor. Until the switch is open, for your convenience sake I am using a switch, but in real time we are not using switch. Until a particular line has to be high, we have to use a resistor and it has to be pulled to high volt, that is VCC. So until that duration your output remains high. Okay, that is pull up. In the same way there is a pull down. Pull down means instead of connecting to VCC we will be connecting to ground, that is called pull down. Okay, in this circuit we are using R1 and R2 as pull up resistors. So both are at high voltage. High voltage means here plus 5 to plus 15, right? So it is plus 5 to plus 15. So I'll be considering as plus 5. Okay, by taking the trigger input pin number 2, low by taking the trigger input low. So I am grounding this. When I ground this, the current flows downwards because it is the least resistance path. So then this line is pulled to 0. Switch is set position, changes the output state into the high state. Got the point? So when I set this to 0, that is low triggering. I am making it into 0. Instead of 5 volts, I am making it 0. When the particular line, trigger line becomes 0, your output starts triggering. This output starts increasing here. Now, how to stop this? To stop this, by taking the reset pin number 4 low, switch is in reset position, changing the output into low state. Now, the switch is toggled to reset. When the switch is toggled, your set becomes 1 and your reset becomes 0. When your reset becomes 0, then again you can see it becomes 0. Low triggered pulse. When it becomes 0, your output goes to 0. Hope you understood. By using trigger pulse and reset pulse, your output will change. So now, when the trigger pulse is 0, when the reset is high, your output remains high. Next, your trigger is 1 and your reset is 0. Let us see what happens. It goes to low and remains low. So that is how your trigger and reset system works in bistable. So this is bistable multi-repeater using Simplify timer. Next, we will be studying about A-stable. Okay, coming to A-stable multi-repeater, if you observe here, pin number 2 and pin number 6 are shorted, which are connected to a capacitor and R1, R2. So this is A-stable, that means high precision frequency generator. So I need a high precision. Here I can have T1 and T2 of a different values. I can change it. That depends upon the formula. We'll come back to the formula in some time. So that is called T on and T off. So T1 is in on, T2 is off. So there are two time duration for T1 to be output should be in on condition and output to be in off condition. That is called T1 and T2. So in the 555 oscillator circuit, as we have seen here, pin number 2, pin number 3 are connected, we know that. Allowing the circuit to re-trigger itself. So what it does, it will allow for re-triggering of itself on every cycle, allowing it to operate on a free running oscillator. So it is an oscillator, it is generating some pulse. It's a free running oscillator. Because of 2 and 6 are shorted, so it will start triggering itself by T on, T off, T on, T off, T on and T off. This will continue. So during each cycle, capacitor C, as we have noted as C1 here, charges up through both timing resistors by using R1 and R2, but discharges itself only through resistor. So it can discharge only through the resistors. So if you observe here, R2 as the other side of R2 is connected to the discharging terminal of 7. So if you see R1 and R2, for charging it uses R1 and R2. So until the charge, your T1 will be on. If you see the capacitance charging, let me explain in this timing diagram. Until capacitor charges to its 2/3 VCC, that is responsible by R1 plus R2 resistors. It goes to high until capacitor charges, your output remains high. Then capacitor starts discharging. So when this capacitor starts discharging, the capacitor starts discharging through R2, only R2, because it is connected to pin number 7. Discharging capacitor is through pin number 7. Now the output goes to low, that is nothing but your T2. Again the cycle repeats. Again the capacitor starts charging. So again the capacitor needs to start charging, means it needs the combination of R1 and R2. It will start charging. When capacitor starts charging, the output remains high. Again it starts discharging. When you start discharging, again your R2 comes into picture because it is discharged through R7. It will discharge. So it's a very simple stable multivibrator. By calculating R1, R2 and C for high, that is T on cycle. For T off, we take R2 and C for discharging. So T on is responsible with R1, R2 and C. For T off, we take only R2 and C. The reason is R2 is connected to pin number 7. So pin number 7 is discharge through the transistor. Okay. Next, we'll go to next one. Here, some of the equations. You'll understand how it works. What are these equations? How it works? I said before, T1 is nothing but on cycle. T2 is nothing but off cycle. So for T2 we use R2 and C. For T1 we use R1 plus R2 into C. The reason is we know R1, R2 and C gives you charging. R2 and C gives you charging. That means until your capacitor starts charging to its peak value, 2/3 VCC, 2/3 of VCC, your output remains high. This remaining output is nothing but a particular time period, that is nothing but T1. Now later the capacitor starts discharging, that is responsible by your R2 because that is connected to pin number 7 of discharging of your 555. Now it starts discharging, your output goes to 0 until next cycle, until it goes to charging, your output remains 0. This is called T2, that is called off condition. This is off condition. This is called T on condition. This is called T off condition. So both T1 and T2 can be of 50% duty cycle, or it can be 50-25%, or it can be 50-75%. You may get doubt how. Let me explain you this. So when I take a graph, if I take T on, T off, T on, T off, T on and T off. So see the width. Just observe the width. Width of T on and T off. 1, 0, 1, 0, 1 I can say. 1 is on, 0 is off. 1 is on, 0 is off. So T1 time duration is equal to T2 time duration. This is 50% duty cycle. 50% duty cycle. Now the question is, what is duty cycle? That is nothing but T on divided by T off plus T on. I'll come back to that in some time. So when I say T is equal to, the total time is nothing but T1 plus T2. So for how much time your pulse is generated? T is equal to T1 plus T2. To calculate T1, we take 0.693 standard formula into R1 plus R2 into C. So here we are taking R1 as well as R2 into C. Okay. So add this and multiply with C will give you T1 time. Next, to calculate T2, we take 0.693 into R2 into C. Why only R2? Because it is a discharging resistor. So that gives you off condition. This gives you on condition. Okay. Next, finding the oscillator cycle time. So as I said here, T1 plus T2. So T1 plus T2 is equal to 0.693 R1 plus 2 times of R2. Why 2 times of R2? Because in T1 we have R2. Again in T2 we have R2. If you take these two equations, you will be getting 0.693 and R1 and C as common. Then 2 times of R2 comes into picture. So that is the reason T is equal to 0.693 into R1 plus 2 times of R2 into C. This is called total time. Okay. Next, coming to find out the frequency. We all know frequency is equal to 1 by T. So that is equal to 1.44 into, it's a standard formula, 1.44 divided by R1 plus 2 times of R2 into C. This gives you the frequency. What is the formula? 1.44 divided by R1 plus 2 times of R2 into C. So this gives you frequency equation. Okay, coming to the last one, duty cycle. So duty cycle is equal to T on divided by T on plus T off. So which are the resistors are responsible for T1, T on, R1 plus R2? For T on plus T off, R1 plus 2 times of R2. So this gives you duty cycle of your 555. Okay, these are the formulas you need to remember. Very, very, very important to solve the problems. Okay. So let us solve one small problem. An astable 555 timer oscillator is constructed using the following components. What are the things they are given? They are given R1, they are given R2, they are given capacitor. What we have to find out? Calculate the output frequency. So we need to find F. We need to find the frequency. And the duty cycle of the output waveform. And also duty cycle. We need to find out. Let us find T1, T2. That's very important to find the frequency as well as duty cycle. So what is T1? As per the formula, T1 is equal to 0.693 into R1 plus R2 into C. So what is R1? 1 kilo. 1 kilo is nothing but 1000. So what is R2? 2 kilo. 2 kilo is nothing but 2000. Okay, into what is the capacitance value? 10 into micro. Micro means 10 to the power of minus 6. So if you calculate this, you will get 0.021 second. Nothing but 21 milliseconds. Okay, so that is your T1. That is on time. On time is 21 milliseconds. T1. This is. Now let us find out the T off condition. T off. This one we need to find out. What is this? T2 condition. We need to find out. So for T2 we need only R2. So what is R2? By the formula, T2 is equal to 0.693 into R2 into C. R2 is 2000 into 10 to the power of minus 6. So you'll be getting 0.14 second. That's nothing but 14 milliseconds. So it will be 14 milliseconds off. So on period will be greater than your off period as per this formula and equations and the data what they are given. So now let us find the total periodic time T. So T is equal to T1 plus T2. What is T1 plus T2 here? 35 milliseconds. So we'll be getting 35 milliseconds. That is your time, total time. This is your total time. Okay, understood? Next, we need to find frequency and duty cycle. That's what they have asked. So frequency is equal to 1 divided by time. So what is the value time? 35 milliseconds. So 1 divided by 35 is 28.6 hertz. This is frequency. Frequency is measured in hertz. 1 divided by 35 milliseconds gives you 28.6 hertz. So let us find out the duty cycle here. So duty cycle is equal to R1 plus R2 divided by R1 plus 2 times of R2. So 1000 kilo, that is nothing but 1 kilo, 1000, 2002 kilo ohm, 1 kilo ohm into 2 times of R2, 2 times of this. It's 0.6, or we call it as 60% duty cycles. In terms of percentage, it will be 60% because T on is not equal to T off. That's what we've seen in the previous slide. T on is not equal to T off because T1 was 21 milliseconds. And what was this T off? It was 14 milliseconds. Right? So that is nothing but 35 milliseconds. So this is not equal. So that is the reason. What is the difference? It is 60% duty cycle. Okay. So this is how we are going to find the frequency and duty cycle. Understood? Okay. Okay. So this completes your module 4. So from next class, I'll be starting with module 5. So revise once again each and everything. If you have any doubts, you can contact me once. Okay. So thank you all.